And good morning to all of you who have joined us for today's session of project implementation. And as Chief did say, this morning I'll be making a presentation on quality control and quality assurance. I would give an overview of quality control and quality assurance and touch on prerequisites for quality control. Then we will look at frequency of testing. So I will start by giving some definitions. So quality control is a process through which a business seeks to ensure that product quality is maintained or improved. Quality control involves testing units and determining if they are within the specifications for the final product. Quality assurance is the process of maintaining a desired level of quality in a service or product, especially by means of attention to every stage of the process of delivery or production. So in the context of our project, whose responsibility is it to do quality control and quality assurance? The contractor for the works is responsible for quality control, and the engineer or the engineer's assistant is responsible for quality assurance. So the contractor should prepare the quality control management plan and submit it to the engineer for his attention. The engineer will vet and then make his comments to the contractor, and thereafter will be adopted for implementation. And then the engineer too would have to prepare his quality assurance plan to be able to perform his responsibility under the project. Quality control of construction materials and products is an essential requirement for obtaining improved and uniform standards of roads. Quality control is an essential part of any production process, and highway construction is no exception. Ghana Highway Authority has a manual we call the Site Operations Manual, and it puts quality control into 3 areas of responsibility. And these are materials control, workmanship control, and geometric control. So under materials control, the contractor is required to test the individual components of the materials that he intends to use for the project and submit the results to the engineer well in advance for the engineer to assess if indeed the materials can be used for the project. The materials meet the specification requirements. Under workmanship control, when the work has been executed by the contractor, we have to check. For example, the pavement has been constructed. Does the subbase meet the thickness requirement? Does it meet the crossfall requirement? In super elevated sections, has the curve been well super elevated to the requirement? So we check all that under workmanship. That is the value of the product that the contractor has given to us. We need to check. And then we look at geometric control. Here we are looking at height, the width of the product, to check if they are within the tolerances. So to be able to do quality control, we need to have certain things in place. Definitely, as we are all aware, we need the specification. So construction specification should provide for effective quality control. Adequately trained staff and equipped agency for exercising quality control should be set up. Periodic appraisal of the quality control data should be made, not only for implementation during the control of the works, but also for effecting possible improvements in quality control and the construction techniques. Updating of knowledge by on-job training. Control of materials. Quality control tests on materials at project sites are essential to ensure that the materials being incorporated into the works are of specified quality. All the materials brought to site shall be stacked and stored as specified so as to prevent deterioration or intrusion of foreign matter and to ensure the preservation of their quality and fitness for the work. Materials which have been improperly stored or have been stored for long periods shall be retested where their suitability in the work is doubtful. So test procedures. The procedures for testing of different materials and work shall be in accordance with the relevant standards and specifications. And usually, the test in terms of the frequency we come to it are actually at the minimum. So we can decide to increase the number of tests that we would have to do. Where specific procedures for testing is not indicated, the test shall be carried out as per the prevalent practice to the direction of the engineer in charge of the project. So we'll look at the frequency and extent of testing. So in the course of the execution of the works, how often and to what extent should we test? The frequency and extent of testing is minimum considered necessary for normal conditions. Additional testing shall be carried out in abnormal conditions where variations may be excessive or where circumstances so warrant otherwise. So we will first start from earthworks. So under earthworks, we will deal with original ground. And for original ground, to enable us check the density of the compacted layer, how are we going to go about it?
Recording in progress.
For every 1,000 meters squared of original ground, we need to take samples, enough samples required to determine the maximum dry density and then the optimum moisture contents. And they are needed to control the compaction. So within that area of 1,000 meters squared, we pick samples and we do the laboratory compaction test to ascertain our maximum dry density and then optimum moisture content. And when we have determined that and the compaction has been done, then we need to determine the field dry density. we have to do our field density test. Within the area that we pick the samples, that is the 1,000 meters squared, the minimum number of tests within that area should be 3 tests. For bulk earthworks, that's where we are doing filling. So in the first place, the materials that we are bringing from the borrow pit or any source that has already been approved of by the engineer. Once the material is brought to the site and compacted in the specified layer, for a compacted volume of 250 meters squared, the compacted volume of 1,000 meters squared, we need to pick the samples and do the laboratory compaction test to determine the maximum dry density and the optimal moisture content. So the values that we will obtain are the ones that we are going to use to control the field dry density. So the field dry density will be determined at every 250 meters squared. And within that 250 meter cube of compacted earthworks, we need to do a minimum of 3 tests. For upper 300 millimeter of earthworks, the samples, the materials that we have brought from the site, the borrow pit, the material is laid and compacted. And for an area of 250 meters squared, we need to pick samples and do the laboratory compaction test to determine the MDD and then the OMC. So for 250 meters squared of the compacted layer, we need to determine the field dry density. We need to do the field density test to determine the level of compaction and also determine the moisture content. And for under the upper 300 millimeter of earthworks, we need to also do the soaked CBL at every 1,000 meters squared of each compacted layer. Here, and under the upper 300 millimeter of earthworks, let's say that we are in a cut and we have cuts to formation. Below the formation level, that's the 300, we need to sample the material, do the grading, Atterbeck limits, do compaction, determine our CBL, and then find out if the material within that cut meets the specification requirements. If it doesn't, then it means that that material has to be cut to spell, or per the assessment, maybe it can be used in the lower layers of embankment. So we move on to backfill to culverts and structures. So under section 7 and 8 of the standard specification for road and bridge works of the Ministry of Roads and Highways. So we will have to do the initial assessment of the materials from the borrow pit and see if indeed it can be used for the backfilling to the culverts, maybe pipe covers, boss culverts, maybe retaining walls and all that. And the specification talks about using the minimum of selected fill material for the backfilling. So we need to do the assessment and see if indeed that material can be used. So once it is brought to site and compacted, we need to determine the MDD and then the OMC and use it to control the field compaction. So for every 10-meter cube of the specified compacted layer, we will do the field density to determine our level of compaction. And this should be done twice with a minimum of 2 tests per that session. Gravel wearing course. We know we have various types of wearing course for our roads. We can also have gravel, natural gravel being used as wearing surface for the pavement. And for every source that we want to make use of the material, we need to do the assessment as specified in the specification under section 12 of the standard specification. And once that is done and the material is accepted for use, when the material is brought to site, for every 350 meters squared, we need to take samples and determine the MDD and then the OMC. So the MDD and then the OMC that we have determined will be used to control the level of compaction within that area from which the sample was taken. So when the compaction is done for the specified thickness of the layer, we need to do the field dry density, determine the field dry density at every 350 meters squared. And the minimum test points within that area should be 3 tests. Soaked CBR and PI for each new source. And every 150 meters squared of compacted material from that source should be determined. And we also have to determine the grading at every 300 meter cubed of compacted material. We move on to natural materials for subbase and base. Natural materials as defined under section 12 of the standard specification. So definitely we will do the assessment, the initial assessment, to take a decision as to whether the material from the borrow pit can be brought to site for use. Under materials control. So once the material is brought to site, the MDD and then the OMC should be determined at every 350 meters squared of each compacted layer. So the MDD and then the OMC that we have determined will be used to control the compaction that will be done. So the field dry density should be determined at every 350 meters squared with a minimum of 3 test points within the specified area. CBL PI grading the plasticity modulus for new source of material, and at every 75 meter cube of each compacted layer from that source should be determined. The ACV, aggregate clashing value, the Los Angeles aberration value, LAA, and then 10% fines for each new source should also be determined under the frequency and extent of testing for natural materials for sub-base and base. Where we are using crash stone for base and sub-base, we will need to determine the maximum dry density using the vibrating hammer method for class D and apparent density for classes A, B, and C. I will amend my presentation. I think it didn't come here, but I will amend it. So for class D, you have to use the vibrating hammer to determine the MDD. And then for crash rock classes A, B, and C, we have to use the apparent density method to determine the MDD for every 2,000 meters squared of compacted layer. So the MDD that we obtain will be the value that we have to use to control the field compaction. So field dry density should be determined at every 350 meters squared with a minimum of 3 test points within the area. We need to also determine the LA, the flakiness index, the 10% fines, water absorption, CBL for new source, and grading PI and flakiness index at every 300 meter cube of materials produced. We come to cement or lime treated materials in subgrade, sub-base, and base. So this session is under section 13 of section 14 of the standard specification. So the initial assessment of the materials, because we are going to make use of cement and all that, we need to check the sulfate content of the material. It's very, very important to find out if indeed that material can be used for cement stabilization or lime stabilization. So once the material has been treated and compacted within an area of 1,500 meters squared, that's 1,500 meters squared, we have to pick samples and do the laboratory compaction to determine the MDD and the OMC. And we use the values to control the level of compaction in the field. So once compaction is done for an area of 350 meters squared, we need to check the field densities and the minimum test points within the area should be 3 points. We need to also check grading, Atterbeck limits, CBR, or the UCS, that's the unconfined compressive strength for the stabilized material at every 300 meter cube of subbase and base laid and compacted. Bituminous surface treatment. We need to determine the flakiness index, LA, 10% fines, the stripping value for new source, and at least once per every 2 weeks. The flakiness index grading spread rate should be done twice a day. Binder quality for every 2,000 liters supplied to site. The binder spray rate once per session sprayed. Bituminous mixes. Asphalt concrete. For the aggregates, we need to determine the Los Angeles abrasion flakiness index, 10% fines, water absorption, Atterbeck limits, bulk, and apparent specific gravities for each new source of aggregate. The mineral filler, we can either be inert or active. We need to determine the grading and then the bulk density once per 100 tons supplied or part of it, and when the source is changed. At the plant site, when the asphalt concrete has been produced, we need to pick samples and determine the bitumen content, grading, stability, flow, maximum specific gravity, and then voice at every 4 hours a day during production. And then on course from the field, when the material has been laid and compacted, we need to take course and then determine the bitumen content, the density, the voice thickness, at least once for every 1,000 meters squared. Concrete works. For the aggregates, we need to determine the Los Angeles abrasion 10% fines, grading, flakiness index for new source, and at every 100 cubic of material supplied to site. The cement, we need to ask for the manufacturer certificate, check for lamps, cubes can be prepared to determine the strength per batch supplied. Chloride content of water should be determined at a frequency directed by the engineer. Slump test for every batch of concrete produced. Compressive strength of the concrete should be determined not more than 50 meter cube of concrete produced or part of it. And 6 cubes, the minimum, should be prepared, and 2 of the cubes tested on the 7th day, and then 4 on the 28th day. Thank you for your attention.